According to the National Electrical Code, or NEC, the Canadian Electrical Code, or SEC, and Underwriters Laboratories, or all standards, when communication cables such as Devicenet cables are installed in the same raceway or wireway as power cables with voltages over 300 volts, the communication cables must be rated for the highest voltage present in the raceway. This requirement is found in NEC Section 800.133 and CEC Rule 800.13.3. An alternative to using a higher voltage rated cable is to physically separate the communication cables from the power cables by a barrier or other approved means. This option is detailed in NEC Section 800.133C and CEC Rule 800.13.3. Devicenet cables are commonly rated for 300 volts. However, some manufacturers offer Devicenet cables specifically rated for 600 volts to meet the demands of installations where they share raceways with high voltage power conductors. It's crucial that the voltage rating of the connectors used with Devicenet cables matches the voltage rating of the cable itself. If the connectors are rated for 300 volts, they should not be used with 600 volt Devicenet cables. A Square D motor control center with Devicenet and Ethernet devices must adhere to the NEC, CSA, and UL requirements. If the Devicenet cable is not rated for 600 volts, it must be physically separated from the power wiring within the wireway. The relevant code sections to consult include NEC Section 800.133, which covers communication cables, CEC Rule 800.13.3, which addresses communication circuits, and UL Standard 60079.14, which pertains to extruded insulation and sheath polymeric communications cables. Let's delve deeper into each of these aspects to provide a comprehensive understanding of the requirements. Firstly, let's examine the NEC Section 800.133 in more detail. This section specifically addresses the wiring methods and materials permitted for communication circuits. It emphasizes the importance of ensuring that communication cables are installed in a manner that prevents them from being subjected to physical damage or interference from other electrical systems. NEC Section 800.133 underscores that when communication cables are placed in the same raceway as power conductors, the communication cables must serve an insulation voltage rating equal to or greater than the highest nominal voltage of any power conductors in the raceway. This requirement is designed to prevent insulation breakdown and potential short circuits between the power and communication cables, which could lead to equipment damage, fire hazards, or even electrical shock. Secondly, consider the physical separation alternative outlined in NEC Section 800.133C. This provision allows for the use of communication cables with lower voltage ratings, such as the typical 300-volt Devicenet cables, provided that they are physically separated from the higher voltage power conductors. Physical separation can be achieved by various means, including the use of barriers, dividers, or separate compartments within the wireway. The separation must be sufficient to maintain a safe distance between the communication and power cables and prevent any accidental contact or arcing. It's important to note that the specific requirements for physical separation may vary depending on the HA, or authority having jurisdiction, and the type of wireway being used. Thirdly, turning to the Canadian Electrical Code, CEC Rule 800.13.3 mirrors the requirements of NEC Section 800.133. It stipulates that communication circuits installed in the same raceway or cable tray with power circuits must be insulated for the maximum voltage of any circuit in the raceway or cable tray. Similar to the NEC, the CEC also allows for physical separation as an alternative to using higher voltage rated communication cables. CEC Rule 800.13.3 outlines the conditions under which physical separation is permitted and specifies the minimum separation distances that must be maintained. The Canadian Electrical Code also emphasizes the importance of proper grounding and bonding of communication cables and equipment to minimize the risk of electrical interference and ensure the safety of personnel and equipment. Fourthly, let's consider UL Standard 60079.14, which focuses on the design, selection, erection, and initial inspection of electrical installations in hazardous areas. While this standard is primarily intended for use in locations where explosive atmospheres may be present, it also provides valuable guidance on the selection and installation of communication cables in general. UL 60079.14 emphasizes the importance of using cables that are suitable for the environmental conditions in which they will be installed, including temperature, humidity, and exposure to chemicals or corrosive substances. It also specifies requirements for cable glands, connectors, and other accessories to ensure that they provide a secure and reliable connection and maintain the integrity of the cable insulation. Understanding the voltage ratings of Devicenet cables is essential for ensuring compliance with the NEC, CSA, and UL requirements. As previously mentioned, Devicenet cables are typically rated for 300 volts. This voltage rating indicates the maximum voltage that the cable insulation can safely withstand under normal operating conditions. However, in installations where Devicenet cables are run alongside power conductors with voltages exceeding 300 volts, it is necessary to use Devicenet cables that are specifically rated for 600 volts or to provide physical separation between the cables. The use of 600-volt rated Devicenet cables provides an additional margin of safety and reduces the risk of insulation breakdown and potential short circuits. Furthermore, the voltage rating of the connectors used with Devicenet cables must also be considered. The connectors should be rated for the same voltage as the cable itself to ensure a consistent level of protection throughout the entire communication circuit. If 300-volt rated connectors are used with 600-volt Devicenet cables, the connectors may become a weak point in the system and could potentially fail under high voltage conditions. In the specific case of the Square D motor control center with Devicenet and the Ethernet devices, it is crucial to verify that the Devicenet cables and connectors are in compliance with the applicable codes and standards. If the Devicenet cables are not rated for 600 volts, they must be physically separated from the power wiring within the wireway. This can be achieved by installing a barrier or divider between the Devicenet cables and the power conductors, or by using separate compartments within the wireway. The separation must be sufficient to maintain a safe distance between the cables and prevent any accidental contact or arcing. It is also important to ensure that the connectors used with the Devicenet cables are properly rated and installed, and that all wiring connections are secure and reliable. To summarize, when running Devicenet cables in the same wireway as 600-volt motor power wires, it is essential to comply with the NEC, CSA, and UL requirements. Firstly, if the Devicenet cables are not rated for 600 volts, they must be physically separated from the power wiring by a barrier or other approved means. Secondly, if physical separation is not feasible, the Devicenet cables must be rated for 600 volts to match the highest voltage present in the wireway. Thirdly, the connectors used with Devicenet cables should be rated for the same voltage as the cable itself to ensure a consistent level of protection throughout the entire communication circuit. Fourthly, it is important to verify that the Square D motor control center with Devicenet and Ethernet devices is in compliance with the applicable codes and standards. Fifthly, proper grounding and bonding of communication cables and equipment is essential to minimize the risk of electrical interference and ensure the safety of personnel and equipment. Sixthly, it's very important to consult with a qualified electrical engineer or inspector to ensure that all wiring installations are in compliance with the applicable codes and standards. Now, let's expand on the discussion of physical separation methods for Devicenet cables and power conductors within a wireway. Several techniques can be employed to achieve adequate physical separation, and the choice of method will depend on the specific characteristics of the wireway and the installation environment. One common method is to use a divider or barrier within the wireway to create separate compartments for the Devicenet cables and the power conductors. The divider should be made of a non-conductive material, such as plastic or fiberglass, and should be securely fastened to the wireway to prevent it from shifting or dislodging. The divider should also extend the full length of the wireway to ensure that the Devicenet cables and power conductors are completely isolated from each other. Another method is to use separate inner ducts or conduits within the wireway to enclose the Devicenet cables and the power conductors. Inner ducts are flexible corrugated tubes that can be easily installed within a wireway to provide a physical barrier between cables. Conduits are rigid metal or plastic tubes that offer a higher level of protection against physical damage and environmental factors. When using inner ducts for conduits, it is important to ensure that they are properly sized to accommodate the cables and that they are securely fastened to the wireway. A third method is to use cable ties or straps to bundle the Devicenet cables and the power conductors separately and then maintain a safe distance between the bundles. This method is typically used in situations where it is not practical to install a divider or inner ducts. When using cable ties or straps, it is important to ensure that they are made of a non-conductive material and that they are applied tightly enough to prevent the cables from shifting or sagging. The distance between the bundles should be sufficient to prevent any accidental contact or arcing. In addition to physical separation, proper grounding and bonding of communication cables and equipment is essential to minimize the risk of electrical interference and ensure the safety of personnel and equipment. Grounding involves connecting the metallic parts of electrical equipment to the earth or to a common grounding point. Bonding involves connecting different metallic parts of electrical equipment together to create a lower impedance path for fault currents. Proper grounding and bonding can help to prevent electrical shock hazards and reduce the risk of equipment damage due to voltage surges or other electrical disturbances. The NEC and CEC contain detailed requirements for grounding and bonding of electrical systems, and it is important to follow these requirements carefully when installing Devicenet cables and equipment. Finally, it is essential to consult with a qualified electrical engineer or inspector to ensure that all wiring installations are in compliance with the applicable codes and standards. Electrical codes and standards are complex and constantly evolving, and it is important to have a thorough understanding of the requirements before undertaking any electrical work. An electrical engineer or inspector can provide valuable guidance on the selection of appropriate wiring methods and materials and can help to ensure that all installations are safe and compliant. Moreover, it's pertinent to underscore the significance of adhering to manufacturer specifications and guidelines for Devicenet cables and connectors. Manufacturers often provide detailed instructions on proper installation techniques, recommended torque values for connectors, and environmental limitations of their products. Deviation from these guidelines can lead to premature cable failure, signal degradation, or even safety hazards. For instance, exceeding the maximum bend radius of a Devicenet cable during installation can damage the conductors or shielding, resulting in reduced performance or complete failure. Similarly, over-tightening a connector can crush the cable insulation, creating a potential short circuit or ground fault. Moreover, exposure to harsh chemicals or extreme temperatures can degrade the cable jacket and insulation, compromising its integrity and increasing the risk of electrical hazards. Therefore, it's crucial to carefully review and follow the manufacturer's recommendations for Devicenet cable and connector installation to ensure optimal performance and longevity. Furthermore, it is essential to conduct regular inspections and maintenance of Devicenet cable installations to identify and address any potential problems before they escalate into serious issues. Inspection should include visual examination of the cables and connectors for signs of damage such as cuts, abrasions, or corrosion. Connectors should be checked for tightness and proper seating, and cable run should be inspected for proper support and strain relief. In addition, electrical testing of the Devicenet network can help to identify signal degradation or other performance issues that may not be readily apparent during visual inspection. Regular maintenance, such as cleaning connectors and retightening connections, can help to prevent corrosion and ensure reliable operation of the Devicenet network. Another important consideration is the proper labeling and documentation of Devicenet cable installations. Clear and accurate labeling of cables and connectors can facilitate troubleshooting and maintenance activities and prevent accidental disconnections or misconnections. Documentation should include cable routing diagrams, connector pinouts, and voltage ratings, as well as any special installation notes or precautions. Proper labeling and documentation can save time and effort during future maintenance or modification work and can help to ensure the safety of personnel working on the system. In summary, when running Devicenet cables in the same wireway as 600-volt motor power wires, it is imperative to adhere to the NEC, CSA, and UL requirements, as well as manufacturer specifications and guidelines. This includes using Devicenet cables that are rated for 600 volts or providing physical separation between the cables using connectors that are rated for the same voltage as the cable, ensuring proper grounding and bonding, and conducting regular inspections and maintenance. Additionally, it is essential to consult with a qualified electrical engineer or inspector to ensure that all wiring installations are safe and compliant. By following these best practices, it is possible to ensure the reliable and safe operation of Devicenet networks in industrial environments.